Now the solvents that you collect with your active ingredient, you're going to evaporate the solvent. Typo right there. You're going to evaporate the solvent. Again, this is where I mentioned on using a water bath or a heating plate. And then while you do this, while it's evaporating, you also cool it to ensure crystal formation. So I think you'll see the slushy-like crystals here. So it's very wet, but you still have crystals that form. So you have to completely dry it. So here it skips the vacuum filtration. That's what you would have done to dry it. This is where you guys have to record the weights. So this is just the filter paper by itself. To record that number. This number is 0.410. 0.410. Why I can't stop this. So, sorry guys, my computer's so slow right now. I have a billion things running. Tabs for my courses and everything. So the paper by itself was 0.410 or 11. I would put 10. It looks like a 9, but it's not. It's a 4. So 0.410 or 411. And then when you add the filter paper plus the crystals, it's going to be 0.7 something, 0.711, I believe. So 0.764. 0.764 for the mass of the paper and the crystal. The paper was 0.410 or 411, and then with everything, it's 0.764. Did anybody not get those two numbers? The mass of the pill is 0. One sec. .62 for the mass of the pill. Grams. 0.62 grams for the total pill. I'm going to continue. If you don't have the numbers, let me know. This is the melting point analysis. So this is a machine that you're going to use for observing the melting point of your crystal. So this is a capillary tube, the same tube you use to spot TLC. So then you're just gonna dab a bit of your crystal. Then you're gonna push it down, turn it over, and then push it down. You can see it's in the bottom. When you put it through the slit in the machine. Now pay attention to this next part because this is going to be for your melting point analysis. So here at the start, we're at 153 7.12, I believe. Here's the solid. It's still in solid form, so the temperature is going to increase. This number is going to go up, and you should pay attention to the state of your solid. As the temperature increases, you have to pay attention to both. You have to look at both. And when you start seeing the solid liquefy, so it starts getting smaller, that's where you pay attention to the temperature. And then you also pay attention to when it's completely dissolved or completely a liquid, and then look at the temperature. So based off here, you have to record your melting temperature, and this is for you to gauge that based off your understanding. Going to end right here at 70.6. It ends. I'll go back one more time. Did anybody need me to do it one more time?
Yes, please. Yes, please.
Alrighty. Back. Guys, keep in mind you don't have the luxury of having a video in the lab if we were to do this in the lab. I'll continue after this is done. Again, do you guys, when you're doing this in the lab, you have one chance. So you put the tube in there, you look. If you're not paying attention and you miss it when it dissolves and you miss the temperature, then you have to do it again. So you have to prepare another capillary tube and then keep doing it until you get the correct range. We don't get repeats in a lab, but at least it's not blurry resolution in the lab. I know. Yeah, unfortunately, we got 480, which I don't think is much better. Oh, it's actually a little bit better. There you go. So I'll do it one more time. This is actually a little bit better. I guess the campus doesn't have a very good camera. This looks like a video from like the 80s and 90s for a tutorial on a lab experiment. Is it possible to get the link to the video? Seeing it melt is like framey. So it's choppy, right? Huh. I can't send you guys the link because it contains all the other videos, but